Good morning and welcome to Chapter 10 test. Woohoo! We're so last assignment ever for this year. Yay! Okay, so we've got Chapter 10 test and we're looking at a stem and leaf plot. And basically what we're doing is we're plotting in data. So the stem over here is for our tens column. The ones over here are for our leaf are the ones. So 0 and 9 would be 0 tens and 9 ones. So now we have the tens and we have a missing number here. So we have 110 and then we have an 11 and then we have a 12 and then we have a 14 and a 16, but we're missing one number. And if you look right here, the number that we're missing is 10. So here's our 1 and here's our 0 for our 10. Okay, so for exercise 2, the stem and leaf plot shows the time in seconds it takes students to answer a question in an online assessment. How many of the times are at least 70 seconds? So when we look at our stem and we look at our leaf, we have these right here. This is all the 50s. This is all the 60s. So we need at least 70 seconds. So here's 1, 2, 3, 4, 5, 6. Because this would be 70, 72, 74, 81, 88, and 95. Exercise 3. The frequency table shows the test scores of students in a class. Display the data in an interactive histogram. So you have 2 students for 61 to 70, 71 to 80 points. There was 5 students, etc., etc. So for each of these, you've got 2 for the 61 to 70, and then we have 5 for the 71 to 80, etc. So this is what we're going to do. And we can see that it's skewed to the left because we can see that little tail coming down. This histogram shows the height in inches of several students in a class. How many of the heights are less than 65? So we have to find 65, and then we have to come over here and we see 4 and 2, and that's going to be 6. Exercise 5, we're looking at the shape of the distribution, and we're looking at daily rainfall amounts. And you can see that the little tail or the little thing skews to the right side, so it's going to be called skewed to the right. And so simple again. Describe the shape of the distribution. Well, now it's skewed to the left. And now we're going to plot 5 numbers. We're going to plot the least and the greatest, and then the median, and the first quartile and the third quartile. So we plot the first one, which is the least, and that number, when we look through all of these numbers, is the number 2. And then we're going to plot the greatest number, which is, again, is going to be the greatest number, which would be 19. So we plot that right there. And then we need the number that's between 2 and 19, and that's going to be when we line all of these numbers up. So we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So the number that's in between those 2 numbers, and that number is going to be 12. And so then we're going to look at our first quartile, the number is 6, and then on our third quartile, the number is 17. The box and whisker plot shows the distances in feet of the discus throws at a track and field meet. What fraction of the distances are greater than 58? And your answer is 1/4. Okay, so this is the distance. This is the spread. So they want to know, is it spread out more, the whisker over here? And remember, this is the whisker, or is it spread out more over here? Well, you can see this is a much longer line, so it's spread out more in the third quartile. So the double box and whisker plot represents the daily high temperatures in Fahrenheit for several days in 2 cities. So you have city A, you have city B, and then you have the spread right here, and then you have the spread right here. So which one appears to be more spread out? Well, 65 to 70 is only only 5 difference in degrees, but 66 to 74 is much higher. So that's going to be 8 degrees. So this, you can see, is much more spread out. So B has a more spread. Okay, so the stem and leaf shows the volume in milliliters of food dyed to added several glasses of water. Which statement is not true? So whenever they say not true, it's a process of elimination. So this is going to be 7, 8, 9. This is going to be 11, 11, 12, 16, 18, 21, 22, and 38. So it says the medium volume is 12 meters. So when we count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We would go in 5 this way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And what we would find is the number 2 would be the median number. So the median number is 12 milliliters. So that is true. So that cannot be our answer. The second question is the range of the volumes is 31. Well, if we have 38 and we take away 7 from that, that will give us 31. So the range of the volume is 31 milliliters. So that is also true. We're looking for a statement that's not true. The third is our actual answer, and it says the volume that occurs the most often is 1 milliliter. Well, 1 milliliter doesn't even occur. If you look up here, you might be tricked by that because it's actually the 1 appears twice, but it's not 1, it's 11. This is a 10 and this is a 1. It's just a real quick and easy way to get your numbers down. So the answer that is not true is the volume that occurs the most often is 1 milliliter. The histogram shows the number of students in several classes. The question is, how many classes have at least 18 and no more than 23? So we have to have 18 and no more than 23. So the 24 and this 27, both of these are excluded. And so what we're going to do is we're going to add these two up, and we have 6 here and 5. So 6 plus 5 is going to be 11. Okay, histogram shows how many boxes of health bars the students in a class sold for a fundraiser. What percent of the students in this class sold at least 15? So this question requires us to do a couple of things. It requires us to find out how many boxes were sold total, then also compare it to the number of boxes that were 15 or more. So let's find out how many boxes were sold total first. So we have 5 plus 7 is going to give us 12, plus 6 is going to give us 18, plus 4 is going to give us 22, plus 3 is going to give us 25. So we have 25 boxes total. So for this question, we're going to use this 25. We're going to make it into a fraction, and then we're going to find out how many did they actually sell that were more than. So now we have to take that and compare it to the number that were actually sold that were more than. So we have 4 plus 3, which is going to give us 7. So that's going to equal 7. Now what we need to do is we need to make this a percent. And remember, percent means of 100. So 25 to 100, how do we get there? Well, to 25 to 100, we have to multiply this number by 4, which means we have to also multiply this number by 4. So 7 times 4 is going to give us 28. So it's 28 out of 100, or 28%. Okay, this frequency table shows the heights of students in a class. Describe the shapes of the distribution. And so we have 5, 4, 3, 3, 3, and 1. And we can already see where it's going to be skewed. But we're going to go ahead and plug it in. And so our first one is 5. So we would pull this up to 5, and et cetera, et cetera, et cetera. Okay. And then what we're going to see is we're going to see a graph that's going to start to go this way. So we're going to say that it is skewed right. The histograms show the temperature in degrees Fahrenheit in 2 cities. Which city has a warmer temperature in July? And when you look at it, when we add up the frequencies, the number of days is going to be the same. What you look at is, without having to add all of this, we can just kind of look to see, these are the higher numbers. Which one has the higher numbers that are taller? Well, over here, yeah, but look at how many numbers over here with lower temperatures, and look at how low that temperature is. So the higher numbers are going to be city A. The dot plot shows the daily high temperatures for several days in a city. What is the most appropriate measure to describe the center? So when we look at this, you can see that little sloping thing goes beep. So it's skewing to the left. And the easiest, or the most accurate way to describe the center would be to count and then find where the median is, because that's going to be the center number. And this is one of those giveaways. When we look at it, we can describe the variation. We can see that it's skewed to the right. See, it's kind of coming down to the right. And then we can also see that the most appropriate measure, and I'm going to give it to you, is IQR. This histogram shows the height in inches of several students in a class. What is the most appropriate measure to describe the center? Well, we can see that this is symmetrical. You can see whatever is happening over here is also happening over here. If we folded this paper in half, it would be the same. And we can also see that the best way to describe the measure would be the mean, because we could take all of these numbers, add them together, and that would be our middle, or our center, sorry. Close to being done. Exercise 19. The histogram shows the number of glasses of water several students drink per day. What is the most appropriate measure to describe this variation? And you guys should all be able to do this. It is called symmetric. The distribution is symmetric. You can see, you can fold it in half. And the blank is the most appropriate measure to describe this variation, and I'm giving you the answer. It's called MAD. M-A-D. Last question ever for online learning for this year. Woohoo! All right. Double box and whisker plot show the prices in dollars of pants at 2 stores. Which store has a distribution of prices that is skewed to the left? And when we look over here, all of this is falling over to the left. All of this is falling to the right. So store A wins. Woohoo! Have a wonderful day, guys. Bye.